So we're going to take ourselves through a couple of video demos in play here. And the first one that we're going to go through is effectively what it looks like to set up WEKA inside of an AWS type of environment. So as noted before, and I think that there was a question saying, how do you size this appropriately? We actually go to start.weka.io, and we actually have a built-in sizer that's available for this environment. You go ahead and you set up, you ask what type of requirements you need, whether it's capacity-based, whether it's performance-based, et cetera, and it will make an immediate recommendation as to what type of instance size would meet those particular needs. Today, it's AWS. As we move into this multi-cloud environment in the future, you're going to go ahead and see a number of things where you'll have Oracle in here, you'll have GCP in here, and so we'll be able to give you the context of which cloud you're looking for. So once you have this in place, you go ahead and you click the Deploy AWS button. It brings up a few additional questions for you in terms of what you're looking for, right? Do you want to add additional clients to the environment? Which version of WEKA do you want to run? And so on and so forth. When you click Deploy AWS, what it's going to do then is build a CloudFormation template for you. Once you have that CloudFormation template in place, it's going to ask for a few additional questions, such as types of networking, security, what type of EC2 configuration you're looking for, SSH, logins, et cetera. And at that point, you literally just click Create Stack. Once it does that, you go into the CloudFormation section of your AWS console, and you can see that it's already taking that and doing a full deployment.
For the section where you were talking about the EC2 deployment types, what criteria are you basing that upon? Is that part of the calculator that you were talking about, where it walks you through it, or how do you know which types to use, and are you measuring that against a price point?
Yeah, so if you go in there, you'll have to go ahead and determine what the price point is of it, but you can go in and set triggers to say, are you optimizing for performance? Are you optimizing for capacity? And then we give you the whole list of options. So you may come up with a situation where you say, for performance, you'll need something that has a higher CPU count, core count versus number of NVMe devices. Or it may go the other direction where you're capacity based and you want something that has lower CPU, higher NVMe. But either way, it'll give you that full list, and you can go through and choose which one you believe is optimized for the point you're looking for.
Gotcha. Thank you.
Okay.
Is it possible to change the instance sizes after the fact?
Yes, you can go in and modify your CloudFormation template and then go ahead and add and change it as needed.
Okay.
Okay. So once you're inside of the AWS console environment, you can see all the events here. It's going ahead, it's building out, it's creating all of the network policies, the access policies, all of essentially the underlying EC2 infrastructure that's behind the scenes. Once you get past this point, oh, by the way, this is your CloudFormation template. So again, we're trying to make very simple something that is highly complex behind the scenes. Once it's in place, we're going to go ahead and fast forward here and refresh to the point where we build out the entire EC2 environment. Now here you're starting to see these things called backends and clients that are being built out. This is where we're beginning to deploy the naming conventions for the EC2 cluster. And then on top of this, we're going to begin to load the WEKA software on top of it. So we provide all the automation to load everything into place, bring it up as a WEKA software cluster for our data platform. There we go. And the way to tell that it is up and running is when you eventually go here to the outputs screen, coming up. It'll actually give you the URL to get to our GUI that you can log into it. Now, in all truth, this probably is about 20 minutes or so of the entire time to set it up, because you have to build the EC2 cluster, You have to lay out all those resources in AWS. Then we have to load the WEKA software on there, build the WEKA cluster. But at that point, away you go. First login, it's going to ask you to change the password, basic security. And at that point, once it's up and running, ta-da, you're inside and you now have all the data services that WEKA can provide. All right, so that's the first part of the demo. The second part here is now we take a typical type of customer, and we're going to have a lot more information. This actually is a customer environment. Ephraim will be talking about this a lot more later. This is the how, not the why the customer is doing this to a large extent. But essentially, this is building into an EKS environment. This particular customer is running Elastic Kubernetes Service, and they had requirements around availability, performance, and a few other things. And so this is deploying a multi-AZ WEKA cluster to go ahead and address that EKS environment. So the first thing we have in here, I just want to show you, is a set of organizations for multi-tenancy. This particular customer has multiple orgs set up, and it allows certain layers of access to the data and the file systems that are within the WEKA environment. Oops, just fast forward through here. We can see that we have a certain amount of environment of capacity set up. The next step that they're going to do is they're going to go ahead and they're going to do VPC peering across their environment. So they want to make sure that this WEKA setup, which is running across multiple AZs, is connected to the EKS instance. Again, that's running across multiple AZs for reliability. And forgive me, there's a lot of blur out here because there's definitely security things that we don't want to be showing out to the rest of the world. Okay, so we have a set of VPCs that are in place. In this particular case, this is the WEKA one. Now, if you notice the CIDR IP, the subnet here, it's the 10.5.00 with a /20 on it. You'll see that repeated again and again, especially when we do the actual peering component in here. All right. Now, there's 6 different networks that are associated here. The first 3 are private. That is the data plane across here. They want to make sure that VPC is peered out. They have all the security that's available in the environment. The public ones that were shown are strictly control plane. That's how you're going to go ahead and manage the WEKA system. It's how you're going to manage the front end of the EKS service before you get to all the pods and all of the worker nodes in there, et cetera. But the great thing is that even though they're set up as VPCs, you can peer them out for common access here. And again, you can see that the CIDR there is in that 10.5 range again. Fast forward a bit more here. Okay. Here's the peering connection that was made between the two of them. And you can see that you have the requester VPC and the acceptor VPC. So that's going to be obviously the WEKA one for the requester, or sorry, yes, and then the actual Kubernetes pod set is going to be up on the acceptor side. So we're putting them together. In this particular case, they're using K9S in order to manage the environment. And we're looking at this from a pod context for this bash development environment use case. Now, what you're seeing on screen here is a whole set of pods that are being used for different services. The CCH namespaces that are on the left-hand side here are applications that are in place, certificate managers, et cetera. Down below, the DMAs are different types of functionality within the Kubernetes environment. But the important ones that we kind of want to look at right now are these ones that say CSI WEKA FS. In this particular case, we have a WEKA controller, which essentially is our CSI plugin that we have available. And then below it, we have these various worker nodes, which are effectively physical EC2 instances. And those EC2 instances then are going to have sets of pods and containers that run on top of them. The controller will present that data as needed on request. So if you build a container, you build a pod, we're going to pass the data through so you can actually see that mounted file system within the container itself on demand. All right. Just fast forward here for a minute. All right, there we go. So we're going to go ahead and we're going to log into one of these worker nodes underneath the covers. In this case, we'll just go in. We're going to go ahead and log in with the correct organizational context so we can actually see the appropriate file system. And, sorry, some of this is in real time for the typing. I apologize for that one. Right? We're going to go ahead and do a local WEKA status. You can see this is the client that is running. Now, as Shimon mentioned earlier, right, we have clients and then we have the actual storage servers behind the scenes, our backends. In this context right here, when it says containers and nodes, what we're really talking about is not Kubernetes. We're talking about WEKA storage services within our client. We run fully containerized, which is why we can do a lot of these things of going into multiple clouds, because we're just creating containerized storage services. Well, our POSIX client is also fully containerized. And so what you're seeing here is we have two essentially IO processes that are running within the container that we're deploying on top of that worker node. And then that's what's going to communicate back to the core storage cluster itself.
So the actual communication that's happening between those pods and the WEKA storage layers is using the WEKA FS?
Absolutely.
Okay.
So we have a client that talks to WEKA FS. Correct.
So if you were going to consume this not from Kubernetes, if you were going to consume this from another EC2 instance as like NFS, do you have to deploy an NFS server to do that WEKA FS to NFS translation?
No. So we are multi-protocol. If you have a client that wants to talk NFS, we are the NFS server. If you want to talk a native POSIX implementation with all this cool acceleration and the ability to look inside the cluster with even greater levels of detail, then you just deploy the WEKA POSIX client out to that application.
Okay. Okay. So that would run locally. You're just doing that through a pod in the Kubernetes.
Exactly. And the whole point here is that we give you this complete elasticity inside of that Kubernetes environment, because you're able to see it both at the physical host, the pod level, and as you'll see in a minute, inside the container itself.
Okay.
But I'm giving away the plot line here, so we'll move forward a little bit. Okay. So again, you can actually see here what the inside of the WEKA cluster looks like. So let's move forward into looking at it from the from that worker node level and what's presented to the pod. We actually have a WEKA mount, and there's that bash file system that we talked about before. So there it is, very small right now. This particular customer actually runs a lot of these file systems because they have massive scaling. They have thousands and thousands of customers, and they're all running them across multiple systems. Fast forward a little bit here. Okay, you can see that same container that's running. There we go. And now we will go into the actual pod level and container view. So the file system, we're going to go in. We're going to go into this CCH CIS server here. And container builds out. And there you go. Inside of the pod itself, there's the entire set of file systems. All the mounts are in place. And as you can see, there's the exact same set of data right there. That's CCHA bash file system, fully available, looks exactly the same as it did below. And so now anytime you provision a container within that pod, this automatically pops up and says you have a mount that is available to it. And it's that same file system.
Function. Well, what's performing the mount function there?
So it's actually the CSI driver. It goes ahead and says and uses the container interface and says, great, go ahead and provide this mount to the inside of that container when it's provisioned.
All right, thank you.
Yeah. All right. So then comes the next part, which is, so now we have this customer who says, I'm doing this killer scaling, I'm doing very elastic, I'm using Kubernetes. How do I go ahead and do the types of things where maybe we want to grow, maybe we want to shrink our environment, make it as dynamic and elastic as the cloud really wants to provide? So we're going to go ahead and I'm going to show you a little bit about how to do this. So fast forward through the slide stuff. There we go. in a nutshell, the process that's going to be used here is we're going to go ahead and set up a cluster in the same manner that I showed you earlier. Then once it's done, we've built out this entire stack inside of AWS. We're going to go grab a little bit of WEKA code on GitHub, which is going to enable Lambda functions, and it's going to enable EC2 autoscaling groups. Once you build this in, you're basically going to go into your autoscaling dashboard, and you can just click what size you want to change the environment to, and we handle all of the calculation behind the scenes. So what we're seeing here right now is we have a 8-host WEKA cluster, and it's called ASG demo. It's running inside this AWS environment. We've automated this environment pretty heavily on the back end. So one of the things that WEKA is doing is that we're providing things like Ansible scripts, Python-enabled code repos, GitHub, and then Jenkins, things like that, where we're going to automate this entire process across the board. We allow customers to do this. We give them generic versions of this so that they can get jump started on automating their own environments if they want to build environments on demand and things like that.
Mm-hmm.
Let me go ahead and fast forward here. So we start out here. We already have that cluster that was built. It was 8 hosts. Now we're going to tell them, let's go ahead and build this pipeline where we're going to grow it up to 16 hosts. And eventually we're going to shrink it back to 8. We're automating this entire thing in a Jenkins build, and we're going to showcase this for the entire process here. So we start out, the very first thing is we're going to run a performance benchmark against the existing 8 hosts. I'm going to fast forward through some of this in the interest of time. And we fully log the entire environment. And eventually we come up with a performance number. There we go. That's available in the environment. It's hard to see there, but we were pushing 17 gigabytes a second on a relatively very small cluster. I think this is i3 EN4XL X-large instances for those 8. All right. Next step now is we're going to go ahead and apply the ASG function, which is going to go ahead and grow that cluster. The pipeline goes in. There we go. There's the FIO. Builds the pipeline for it. And then what it's going to do now is it's going to add the EC2 instances like we showed before. And then it's going to load WEKA software on top of those EC2 instances. And once they're in place, the whole cluster will begin to rebalance. As Shimon mentioned before, because we do everything virtually inside of these containers, we do metadata functions, et cetera, it begins to phase the new hosts in. It brings it up to full data redundancy within the system and gives you exceptional performance as it goes forward. As you saw, we moved to 16 hosts in the cluster that easily. And by the way, this function, it timed out. That was 18 minutes to do that, to double the size of the cluster there. And then we're going to run FIO again, just to give a little bit of a performance function. And here's kind of the payoff. At the end of it, we went from 8 hosts to 16 hosts. And as you can see, the performance is extraordinarily linear. We basically doubled the read performance. We doubled the write performance. IOPS, there's a little bit of a difference in terms of how much CPU was used versus how much NVMe. So it's not 100% linear on the reads. But on the other hand, our write IOPS, we tripled them just by doing a quick scale up. And so when customers are trying to be really elastic, this is something that's very important to them. And then at the end of the day, we can go ahead and finish that pipeline off by running ASG again, and it begins to decommission the EC2 instances out of the system, rebalances the data back to the size of the original cluster. Again, if you have more data than can fit in the original cluster, you need to have some mechanism of offloading it, whether it's dumping it off to an object store behind the scenes or whatever other mechanism. But it's literally that simple.
I saw there you had the data protection value was set to 4+2. Was that part of 6 nodes?
Yeah, so it's the striping value. So we go ahead and essentially have 4 core data stripes and then 2 effectively call them parity stripes.
So you could lose 2 nodes and not.
We can lose two whole failure domains, and it will continue to run with 0 performance loss.
And how do those values change as you scale into tens, hundreds?
Yeah. So you make the decision up front what stripe size you'd like.
Completely customizable.
Yeah. Well, you're going to have to make that fixed decision up front.
Okay.
But if you think you're going to grow later on to maybe a larger cluster, et cetera, then generally we'll recommend to go to a larger stripe size to optimize the environment.
And if customers were running 100 nodes, what type of traditional size?
16 plus 4 is very typical.
Okay.
And we get maximum performance with that small of a stripe size. It works really well.
Let
me move forward here because I want to make sure that for time we get our next presenters in. So the final demo here is we're going to talk about multi-cloud data portability here. And this particular demo is something that was very unique to us a while back. We've had this technology called snap to object. And it's the idea that we can take a snapshot of data, make it incredibly portable by taking both the metadata and the data itself, package it up and send it to an object store. Now, this is based on those 4K granularity, really distributed snapshots that we have within the system for high performance. It's instantaneous. There's no impact to the system, but it makes sure that the data moves appropriately. So what I'm going to show today is we're going to go take a snapshot that's in one public cloud, move that data to an S3 object store in a second public cloud. And then at that point, we're going to spin up another WEKA cluster, attach that data, and now you're going to be able to see that data regardless of where it is. This is a full cloud use case, but as Shimon mentioned earlier, this can be hybrid. It can be on-prem up to cloud, cloud back to on-prem. We can even take snapshots of the moved data and send them back to the original location or other places. So let's go ahead and just dive right into it. So we start out here with this particular cluster. It's inside of AWS. It is a relatively small cluster. In this case, it's only 6 hosts, very small core counts, et cetera. We are now going to attach it to or have a object store bucket that we're going to call in Google Storage that is going to attach to that cluster. Now, just to show you here, this is actually using the Google APIs. So this is Google Cloud Storage that we're attaching to. So AWS WEKA attaching to Google Object Store. Not something you'd traditionally see happening out there. Oops, there we go. All right. So we go in and we have this particular file system that's in place. It's relatively small right now for purposes of this demo. The file system actually has that object store bucket passed through to it so that we can make this capacity extensible. If we go to the command line inside of Amazon on one of the clients that's attached to the WEKA cluster, I'm going to go ahead and look at a mount location. I've already pre-populated some data into the environment. And in this case, I've got 1,000 1 meg files, and I've already embedded the checksum for the file within the actual file name itself. Or let me be very clear about it. Someone else who's very smart at WEKA did that for me, and I'm just doing this to show them. So I'm actually going to go ahead and run a second checksum against this. And as you can see, the checksum ID on the left actually matches the file name that's on the right-hand side. And as we note here, the file name starts with FFAEB. That'll be actually kind of important later on. All right, so now we go into that file system that's containing that data, and we're going to go ahead and just create a snapshot. Very simple through our UI. You give it a name, you give it an eventual access point if you want to look at it locally. Click create, you're done. That fast. Next step right after this is we're going to go ahead and we're going to upload this to that object store. And again, it takes the metadata and the data and bumps it up. Now, when it does this move, the one key thing that you need to have is what I'm highlighting right here on screen. And that is the object store locator. This is the root ID of the object for the entire file system tree in the object store. If you don't have that, you can't go and recover that snapshot into the second location. But it's easy enough just to go ahead and do a copy and paste on it. All right, now we have a second cluster. Different size. This one is actually running in Google, but we're attaching to the exact same object store that Google API. All we need to do now to get to this data is create a new file system. So we'll give it a name, AWS Data. We'll turn tiering on, which means it's going to attach to that object store that we've presented to this new cluster. We'll give it a file system size. And then the final part right here is we're going to click that button from uploaded snapshot. You enter that record locator, click create, and now what it's going to do, it's going to go find that object, pull in all the metadata of that system, populate the metadata in place. You have quick access to what the file system and file structure looks like, and then it'll slowly pull the rest of the file system, the data actually into that environment, and it's recreated the entire file system that simply.
Are there any data reduction principles in play here? Obviously, you're going from one cloud to another. There's egress charges. Are you doing anything to minimize the amount of egress?
In this demo, no. However, with the WEKA 4 platform, we do have data reduction that's available. It's a delta compression type of mechanism.
Okay.
Anywhere 2 to 6x reduction is kind of typical, but again, as always, your mileage may vary depending on your data type. I'm not going to commit to
obviously, yes,
straight up.
Yeah.
Okay, inside of Google, I'm going to go to that command line again. And just to prove that there's no smoke and mirrors, I'm actually running a command because Google doesn't advertise their Linux type on their instances. But in this case, there you go. We're running on C2 standard 16s. I go in and I've pre-created an empty directory called AWS Data. And as you can see here, we mount it up. We CD in, check summit, and voila, FFAEB is at the bottom. The exact same consistent data that was on the AWS cluster is now completely available in Google, just by using snap to object and doing data portability. We try and make multi-cloud as simple as we can.